Hello and welcome to another video. In this video we're going to be working on grid game. And I think this is like a really popular interview question, so a good one to know. So in this one you're given a grid of size 2 times n, where basically you have some number of columns and then you always have 2 rows. And then you have a robot that plays with another robot that plays a game. So the first robot starts here. And the only way it can go is right and down, so it takes some path. And what you want to do with the robot is basically the first robot, whatever path it takes, all of those values turn into 0. And then the same robot can do the same thing after the first robot goes. And the goal of the first robot is to minimize the second robot's score. So you want to figure out what's the, if the first robot plays optimally, what's going to be the second robot's score. And they kind of show you this in this example. So the best path for the first robot here is this. All of these values go to 0. And then what's going to happen is the second robot can only take values from the top or bottom row, because no matter what you do, like no matter what path you take, like if we look at some paths, let's say the first robot goes like this, then these values won't be 0. So the second robot will just take whatever's left from the top. If the first robot goes like this, then you're either going to have this value or this value. Or if it goes like this, you're going to have this value. So essentially this goes like this, and then the second robot does this and has a value of 4. So the answer is 4. And they show you the same thing in the second example, so it's like this. So let's make a grid. Actually, they have it here. So let's take a look at all the ways you can go. So like this is the best, and then basically this will all get zeroed out. And then the second robot will just take all of these numbers. But essentially that's the first thing we recognize is no matter what the first robot goes, so like if the first robot goes here, the second robot is only taking values off the top. If it goes like this, then the second robot is either going to pick this or this. If it goes like this, then it's going to pick this or this. And then if it goes like this, it's going to take this. So there's no way for the second robot to get values off the top and the bottom. So basically you want to figure out, like, of all the paths that this first robot goes, what's going to be the score on the top for the second robot and the bottom, and take the max there. So the pseudocode will be something like check path for robot 1, and then robot 2 will have score equal to the max of top row that's remaining or bottom row. And then the answer is min score calculated for robot 2 out of all paths for robot 1. So basically the thing you want to recognize here is like what would be the brute force, I guess. So the brute force would be the first robot actually has to go down at some index, right? So it basically is going to go across some distance. It's going to go down at some index, and then it'll keep going across until it gets to the end. So it can go down here, 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 or here. And wherever it goes down, that gets zeroed out. And then the top row is going to equal values after it goes down, right? Because if, let's say it goes down here, it'll look like this. The top row will be all the values after it goes down, and the bottom row will be all the values before it goes down, because once it goes down, all of this gets zeroed out. And also we can notice, like if we look at all the different paths, like let's say we take this path, the top row will be these 3 values. But if we take the next path, the top row just loses 1 value, and then the bottom row gains a value. And if we take this path, the top row loses another value and the bottom row gains a value. So basically the bottom total keeps extending by the number right before you go down, and then the top total keeps decreasing because you go down further and further and further down. And so what we can do here is we can just calculate, we can just say okay, let's just get the total here beforehand. And then as we go down in different places, we'll keep subtracting from this top total and we'll keep adding down here. So what's that going to look like for this example, I guess? So let's take this guy and just make a new matrix. So we want this to be 4 by 2. So we can just copy that. And this will be column 3. Something like that. Okay. And then we can get rid of all of this. So essentially what we can say is like, all right, let's just get the top total and let's get the bottom total. So the top total here for this example is going to be 20. And the bottom total, so top, and the bottom total is going to start out at 0. Yeah. So 20 and 0. And whenever we choose to go down, we're going to subtract from the top total, like whatever index we're at, because that's no longer going to be part of the total. And then when we go to the next cell, we're going to add the cell we just had. So what's that going to look like? And then we're trying to minimize this like score for robot 2, so we can just initialize it to like infinity or something, like normally. So you can just make this infinity. Okay. So if we choose to go down here, then we're going to subtract this total right here. So essentially we can write that down here. So these are all the numbers that we're using. So in the beginning, basically, like all the top numbers are there and the bottom numbers are not used at all. So if we choose to go down this path, we're going to subtract this number here. So our score will be 19 on the top and then 0 on the bottom, right? Because basically our path will be this. And so then as the bottom robot, you're just going to take the max of these two, because like I said, you can either get the top row or the bottom row. So here the result's 19. Okay. Now when we go here, now we need to add to the bottom total, because now this number is going to be part of the bottom total. So this 1 here is going to be part of the bottom total. So now the bottom total is 1. And now our path is basically this. And we also need to subtract this from the top total, so this goes away. Oops. Okay, so this goes away, gets subtracted from the top total, so now we have 16. And here's the path. So, yeah, so for this path, once again, as the bottom robot, you're just going to pick this. So the total is going to be 16 here. So this is our new updated result because we're minimizing. Okay, now if we choose to go down here, once again, we're going to subtract this guy. So top total will be 15. And we're going to add this guy here, which is 3. Because the new path is this. And then top is 15, bottom is 4. And we're going to choose the top, so we'll get 15, so the best is 15. And then last path, we're going to subtract this here. And we're going to add this, which is 3. And now our last path is this. And now as the bottom guy, you're going to take this. This is 7. So that's the main idea here. We can just basically calculate a total ahead of time. And then subtract from the top row and add to the bottom row and pick the best of those two. And then the smallest result for robot 2 is going to be your answer. So hopefully that makes sense. All right, so let's code that. So we can just say like the total is an array of length 2, and it's kind of annoying once in 64. So the top total will be 0, bottom total will be 0 for now. Let's get the number of columns for the grid. And let's iterate through the top row and just calculate a total there. So 0. And we're going to add this to the top total. 64. Go typing is kind of a pain. So because this one's in 64, you have to convert everything to N64 because grid is int and not N64. Okay. So we're going to have a result. We're going to make it N64. And then this is basically infinity in Go. Same thing. Okay, so now we're going to loop through, and then whatever column we're on is going to be the column we go down at, right? So if we're at this column, this is where we go down, and so on. And so we're going to do our calculations just like in the picture. So we're going to subtract the column we're going down from the top because that column will get zeroed out. So totals at the top row will subtract grid at this column at the top row. Okay, total, I guess. And then now we're going to check. So basically we're going to subtract the one we go down, and now we're just going to take the maximum of the top and the bottom. So and then once we go down this thing, then this cell should be available for the next column we're at, right? So if we go down here, basically what we did is like, if we say let's go down this way, we subtract this number, we go down, we get our thing, but then for the next column, this should be added to the bottom. So we can add to the bottom before going to the next part of the loop. So we can just say total 1, add that value that we need at row 1, and then just return the result. Essentially, our choices for the second robot is take the maximum of whatever's left in the top and the bottom, and then the result is going to be whatever the minimum of those results is, because we're trying to minimize the score for the. So a little bit confusing where you have like a bunch of maximums and minimums, but basically that. You can use like prefix sums as well if you want to, but you can also calculate this on the fly like I showed you, so no need for that. So this is optimal for this guy. This is linear and 1, because we just have this, and we just calculated sums on the fly. Oh yeah, so hopefully this is helpful. If it was, please like the video and subscribe to the channel. Definitely a good problem to know. I guess we can look at, does it have companies on here? I guess not. But yeah, I feel like, maybe it doesn't see it, but I feel like this is a pretty common problem. So, and I think this is like on the blind 75 and stuff. So yeah, that's going to be it for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.